Welcome, my friends. We'll get Lab at Home started here in just a moment. We're going to give you all a little bit of time to arrive. If you would like to introduce yourself in the chat, we would love to hear from you. I'll go ahead and introduce myself in the chat. Whoops, here we go. If you would like to say your name, you can also say your age and where you're watching from if you would like. Hey there, Fletcher. We would love to be able to say hi to you. Both Fletcher and Spencer. Hi, guys. Hi there, Lucy. Oh, yeah.
That's me.
Oh, yeah, we have a special guest today.
I'm the special guest.
Hi there. Is my mic working? Sorry.
Yes.
Yes.
Hi there, Hurdai. Hi there, Frankie. Hi there, Abigail. Hi there, Henry. Hi there, Alexa. All right. Hi there, Liliana and Mia. I think we're probably good to go ahead and get started here. Hello to Cecilia. We have someone who is in this morning's little lab at home as well. That's so much fun to see you guys here today, actually. And I remember that Hurdai was there as well. So that is so awesome to see all you guys here. I'm gonna go ahead and get started with like our few announcements, but then we will get ready to start our experiment today. So hello, my friends. I am so happy to be here with you today, as always. I want to thank you for supporting us, pausing our programming yesterday in solidarity with Shutdown STEM and Strike for Black Lives. Here is a link in the chat if you want to learn more about those ongoing efforts. We are all learning to be in this world, and we all share this world. And part of being a good scientist is keeping an open mind and exploring different perspectives. This skill, which makes us more observant, informed, and compassionate, can be practiced in many different ways. Like today, we'll be exploring the properties of water from a kind of different angle, a different insectoid angle. As you may have noticed, we have another friend in here with us today. Let me introduce my good friend Jenna. I'll let them say hello.
Hey guys, I'm Jenna, and I'm going to be doing some cool stuff with water with you guys today.
I'm so excited for you to facilitate here with us, Jenna. I'm going to go ahead and do our usual opening, which is, as many of us know, our learning process is all about respect for ourselves and each other and our world. We ask you all to show respect by using kind language and appropriate words in the chat box, as this is a program for everyone. My friend Max is moderating the chat and can disable it for any individual users if that is needed. That said, it's okay to disagree or share your feelings. We welcome all ideas that are founded in respect and invite all of you to do the same. When we have the lab on site, we encourage learners to lead with their questions and ideas. So Jenna will be asking you plenty of questions, and we hope that you will share your ideas and your own questions as much as possible in the chat. One last thing, of course, we are still celebrating our summer bug out all through June. That is our first ever virtual event dedicated to exploring the world of bugs and getting to know our invertebrate neighbors. All through June, we are having special bug-centric labs at home. We are featuring 1-minute bug hunts with Dr. Eleanor on our YouTube channel. And because insect appreciation is an art as well as a science, we have our weekly bug out creative challenges with fabulous prizes. More about those challenges later on our Facebook page. Without further ado, I'm going to go ahead and hand it over to my friend Jenna. I hope that you guys will have lots of awesome questions and thoughts and ideas like you usually do. I will hopefully catch you. I will catch you guys next week.
Thanks, Peregrine and Max. I really appreciate that wonderful introduction. I'm glad we all got to get our, our expectations all set. And I am really excited to be talking about insects and bugs with you guys today, especially aquatic insects, because we're going to be talking about bugs and their relationship with water. I am super excited because I love insects and invertebrates, and I've done a lot of looking for insects and invertebrates in different bodies of water myself. So without further ado, let's get to it. So um, I think when we think about how insects and bugs experience the world around them, we have to think about it when as the world being way bigger than the insects and bugs are, because when we are in water, we're able to swim around and we're able to touch it and we're able to drink it, but insects and bugs experience water a little bit differently. They experience it, instead of like a gel like substance, which I think is, and it's a sticky and dense substance, which I think allows for insects and bugs to do a lot of things that humans can't do, which I think is really fun. And one property of water that we're going to be really focusing on today is called surface tension. And you can say in the chat if you guys have ever heard of this, these two words together, surface tension. Thank you, Max. Surface tension is something that water has, which makes it resistant to force around it. Oh, thanks for sharing, Kevin. So raise your hand if you have ever dropped any water on a penny before. And think about what happens when you drop some water from your water bottle onto a table and it looks like a water droplet. Have any of you guys ever done that before? Oh, thank you, Max. So sometimes when circumstances are just right, when a water droplet gets dropped onto a table, it ends up being like a little dome shape, right? Or when it's on that penny, it's in the shape of a little dome. That we got some responses in the chat. I see that, and because it's that little dome because of surface tension. So the little tiny water molecules, little tiny pieces that makes up water. Oh, there you go, Cecilia. It stays on the penny and does not fall off. That's exactly right. The little tiny pieces of water, the water molecules that make up liquid water, have a forces that kind of draw them together. They make them really like each other. And that force holding other water droplets next to each other is called cohesion. Now, when we think about water sticking to other surfaces, so water to the table or water to the penny, that's what we call adhesion. But this really cool cohesion allows it to support weight. So it allows insects to be supported on the surface of the water. We think of like maybe a puddle or maybe a bucket of water that had some like mosquito larvae in it, or maybe even a water strider that uses the water, that can walk across the water, just like we can walk across the ground. Now, have any of you ever tried, when you were jumping into the pool, to see if you can walk across the water really fast? Does that ever happen? Are we able to walk across the surface of a pool? Yeah, I see my friend says, no, we can't walk across the surface of a pool. And that's because our weight, all of our weight is on our feet. But insects and bugs and other things too are able to spread out all of their weight, and instead of it being on one point, they can spread it out using these really tiny hairs that are all over their legs, so it spreads out their weight and they're able to walk on that water. So my friend Max, I got some really neat pictures of different examples of surface tension and insects using that to, there we go. Thank you for sharing that. Can you go to the next slide? And some more, and then the next slide. And yeah, there we go. So we have some insects here. If you can just keep clicking, like I think 6 times max, there are going to be some insects showing their use of their relationship with water, so they have these tiny hairs, micro hairs, that spread out their way onto the surface of the body of water, and they can move on top of the water, just like you would move on top of snow if you had snowshoes on instead of sticking right on it. Now, some of these bugs are on the surface of water, but some of the bugs are under the water, and I would talk a little bit about that too. So some bugs, oh, thank you, Max. This particular bug that has Max's cursor over it is a diving beetle, and they're using that pocket of air on their bottoms, and they're able to breathe with that bubble, which I think is really, really cool. They're able to trap that air and use little tiny holes in their exoskeleton called spiracles to exchange the air when they dive in. Kind of like when you go, if someone goes scuba diving and they have that water tank on their back, or their air tank on their back, they're able to still breathe. And I think that is really, really neat. Another animal that has a cool relationship with water are insects that lay their eggs in their larval stage, or the stage in their life cycle when they are larvae or worms, live in the water. But like we mentioned before, living things need air to breathe. And this, oh, check it out. Nice going, Cecilia. This mayfly larva over here has almost like a snorkel um, that larvae uses to breathe the air at the surface of whatever body of water they're in. So I think that is pretty cool. But back to our experiment, I would love to switch gears a little bit, Max, and I'm going to share my experiment cam so we can start talking about our activity that we're going to do today. So here are some of my materials that I have that we can use to test and experiment with surface tension. And I was wondering if anyone has some materials with us today, if they're going to be doing the experiment along with us. Thanks, Max, for talking up my experiment cam. Oh, Peregrine, you have some materials with us and you are participating with us today. That's wonderful. I don't have any bugs with us, but I do have some makeshift bugs that I used to make, or to experiment with. So I have some little pools of water here. This is going to be our, oh great, Abigail, I love to see that you're going to do the experiment with us. These are my aquatic environments, our water environment for the index card bug that I made. So we can start off with just this insect here. And it's made out of an index card that I cut in half and then folded a couple times. Now you can see that when I set it on my hand, these legs here are able to support that its weight right there. So my experiment, I'm going to wonder to see if the legs of this index card insect is going to break the surface tension of my lake, let's say this lake here, and see, or to see if it will not break the surface tension of this aquatic environment, and use those cohesive forces that are at the surface of the water to its advantage. So I'm gonna, let's see, put this on here and see if it sinks or if it'll float. Check that out, guys. It's getting a little wet, so it's sinking a little bit, but it is floating. Cool, Cecilia. I'm glad you guys made some guesses. Let's see what would happen if I made a different kind. It's got kind of soaking wet here. So let's see if I made a different kind of bug. So I'm gonna try to make a bug that has a different kind of legs. So when we think of like a water strider, it has really, really thin legs. And it has more than just two legs like I made before. So I'm going to see if I can make an insect that has more than two legs. So I'm going to cut my index card just like this to make my insect have multiple legs. So what do you guys think will happen if with my insect that has a bunch of different legs instead of just those 2 long legs? Any predictions? Do you think it'll just sink, or oh, there's a piece of the leg that is floating in another lake over there. Oh, what a great question, Max. So this insect here has 8 legs. So is it an insect if it has 8 legs? Or can you guys tell me what kind of animal has 8 legs? Oh, someone guessed. Nice one, guys. And spiders are arachnids, right? So Cecilia guessed, I don't think it'll totally float, but it'll probably float a little. Someone else said it might sink a little bit. Well, let's just take a look. Look at all these legs that I have in here. All right. So I'm going to put my 8-legged insect into my lake. Let's see what happens. Oh, look at that. It's floating, guys. It is floating. Pretty good. And it's not sinking as fast as my original 2-legged one, too. That's pretty cool. What if I just made one that didn't have any legs? What do you guys think would happen? I'm just going to fold it like this. This is my little insect, and I'm not going to fold again or anything or make any other legs. I'm just going to put it in there and see what happens. That's a great question. Can you think of any animals that don't have any legs? Ooh, a worm. Nice one. Look at that. It is. Oh, it's kind of sinking. It's definitely getting a lot more wet. Let me see if I can show you some perspective here. Yeah, you can see that it is submerged in the water there. It's sunk. It's all the way sunk to the bottom. So I have some other materials. Do you guys have any other things that you think, or how other ways that you guys, if you have the materials, have made your insects float? Did you give them many legs? Did you give them 2 legs? Did you give them any legs? Ooh, Elizabeth, what a great legless animal, a glass lizard. I love that. Oh, sorry about that. So when we think about surface tension, and we think about how insects are able to um, use that surface tension to their advantage. They're not breaking the surface tension. Now, a lot of animals are covered in these waxy coatings, which if you ever, maybe put some, when you're watering your garden and some water got on the leaves, sometimes it rolls off. It's kind of like a smooth feeling on a leaf. That is allows or that property that wax has is called hydrophobic, which means that that property or that material doesn't like water. And a lot of insects with exoskeletons have hydrophobic properties, so the water is just able to roll off of them, and they don't become completely submerged by water. Now, Max, I have a slide in my PowerPoint that shows some ants that are hydrophobic, but then they are covered in something that makes them hydrophilic. Well, this is a great image showing some surface tension. So here is an insect on top of the water, and you guys can see that the molecules or the water pieces that are cohesed together, that cohesion is keeping them together, is allowing that insect to stay on top of the surface. The next picture is showing a really cool example of a human swimming in a pool, and you can see how that water is nicely just shaped over that human, and all of those water molecules are so strong, the forces between them are so strong that they're able to stick together and mold to the shape of a person, which I think is really neat. And I don't remember. Oh, here's another good example of a water droplet showing all of those forces on something that looks to be hydrophobic, so the water can't spread out and make this fabric all wet, which I think is cool. And here we have another insect that is using surface tension to its advantage. But let's see what's happening on the next slide. Next one, Max. All right, so this is the slide that I was hoping to get to. We can see this ant has a droplet of water on it, and it's not spreading out. It's round and pretty small. But then when we move on to the very last picture, we see that that ant is getting covered in water, and it's getting hard for them to move. So we think about insects, they're definitely smaller than us, and a droplet of water like that could be more dangerous for them than us, because it could prevent them from moving around. So what do you think has changed from the first picture to the last picture? I would love to hear your guesses. What do you think has happened that made this ant from hydrophobic to hydrophilic? And I love the way that Max broke down the word hydrophobic. I would love for you guys to, or for Max to break down the word hydrophilic too, similarly. Thanks, Max. Love that. So let's go back to the experiment, Cam. And we can definitely see that something has changed from the first picture of the ant to the last picture of the ant. And I'm going to tell you something that has happened in that particular experiment. So there is a certain kind of caterpillar, a larval stage of a moth, that actually vomits up a surfactant, or something that breaks water tension, or surface tension, and that would helps whatever in or that prevents it from being attacked. So if this caterpillar was being attacked by these particular ants, its defense mechanism, or its way to protect itself, is that it vomits up this particular or substance that breaks up the water tension that's around that liquid, and makes the liquid spread out instead of remain as a droplet. So thank you for that definition, Max. So when we saw that picture of the image, oh, Craig, we prefer barf, got it. So after it barfs up that surfactant, it spreads out all over the ant instead of it being one droplet because of its waxy coating. It spreads all out, and the ants have to retreat, and they don't attack the caterpillar anymore. They have to go and clean themselves off, and in the meantime, the caterpillar can get away. And we are going to demonstrate some of the surfactant with some the surfactant properties of with some household items. So I still have
Uh-oh, looks like Jenna is muted. Every once in a while, it seems like our microphone stopped working. Again, we're still getting used to doing these programs. Jenna, did you figure out your microphone, my friend? Not yet, huh? While they are working on that. Yeah, we can hear you, Jenna. Can you hear me?
Yes, I can hear you. Can you hear me?
Most excellent. I can hear you. We're
Great.
back at it.
We are back at it. All right, so we were talking about using a surfactant that we can find in our house, and I have some soap, some hand soap right here. It's clear, so you can't really see it in my clear dish here. But I also, oh yes, thank you guys so much for being patient with us. So now I have some more materials from my house, and I got some paper clips here. Now I'm gonna take one paper clip and turn it into like an L shape like this. So it's gonna act as a little hook. Oops. Act as a little hook. So I have my regular paper clip too. And then what I'm going to do is I'm going to try to lower my paper clip onto the surface of my little lake here. And let's see what do you guys think will happen to my paper clip as I lower it onto the surface? Do you think it's going to be like the insect experiment that we did, that the paper clip is going to float onto the surface? Or do you think it's going to sink? Love to see your predictions. Oh, I dropped it right there. All right, so that's all right. But what I need to make sure to do is I dry off my paper clip before I try again. And I would love to hear what you guys are doing from home to see if you are getting any different results than I am. Let's see if I can even get it. Oh gosh, there I go again. Dropped it right into the water. It does look tricky because it is super tricky. Let's see if I can try to lay it down in a different way. Just have the quiet silence of concentration. It is just sliding right on off. Let's see here. Maybe if I try to lay it like this onto the paper clip, and that might help it a little bit. Let's see. Oh, you did it. That's wonderful. Let me try one more time. I think also since Peregrine is still with us, Peregrine might have would like to try again with us. Peregrine, would you like to show how it's going over on your side?
All right, let's see if I can get my experiment cam going here. All right.
Nice experiment cam.
Oh, thanks. I've got my two paper clips, and the black one I've got folded into like this L. And I'm gonna try and like use the flat part of the L kind of like a scoop and like lower it down gently, because normally, right, as we've seen, a paper clip is way too heavy. But if we it's rather way denser, right? It can't float, but it can rest Ooh, let's see if it goes. Oh, I got it.
Nice,
Oh,
Peregrine,
no.
on your first try. You're really showing me up here.
No way. No, I had to try many times, and you saw mine sunk right after.
I'm gonna keep trying though, because I feel confident that I will be able to get it.
I'm drying it off really, really well, because if it has any water, that kind of already breaks the surface tension.
All right, let's check it out. Let's check it out.
Do it.
Oh, there it goes. Just had to be patient. Just had to be patient. I don't know if anyone can see, but my paperclip is definitely floating on the surface.
That's fantastic. I'm gonna let you take it away here.
There, I put some green contrast so maybe you guys can see. There we go. It's proof there that my paperclip is floating. Pretty neat, right? So I told you guys that this is going to be all about surfactants, so something that will break the surface tension. So what I'm going to do is dip my finger in the soap, and I'm going to dip it in one of my other lakes, and I'm going to work it into a lather on my finger. And I want to see what is going to happen when I put my finger onto the surface of the water that has soap all over it. Whoa, did you guys see that? Let's see what's going to happen again. Let's try again. Oh man, I bumped it. So did you guys see that? That was pretty neat, I thought. That was cool. I did it one time, which I think is nice, and that's really all you need, right? So you guys saw that my surfactant, my soapy finger, broke the surface tension over or near the paperclip, and my paperclip moved a little bit. It was jolted by the other water molecules because they were being broken, so the other ones were being moved over. So I thought that was pretty cool. Did anyone have that reaction happen when they were practicing it at home or trying it out at home? I thought that was so cool. Well, so when we think about oh great, excited to try it later. That's awesome. So when we think about those poor ants that get covered in caterpillar barf, we can think that all of that water or all of that liquid is just covers their bodies, and all of the surface tension from that liquid has been broken, and they have to just go home and clean it all up. But I appreciate you guys so much for bearing with me through technical difficulties and paperclip difficulties. I appreciate you guys hanging out with me. But that wraps it up for today. And thank you guys for being here. And if you want to share your experiment or any other ideas with us, you can post it on social media and tag the museum with hashtag lab at home. And we would love to see your experiments that you guys did today. Next week, we're going to continue our summer bug out celebration with behind the scenes tour of the butterfly house. And I'm sure you guys will be happy to see Peregrine again and to have Peregrine's expert facilitation skills with you guys to tell you guys all about how all of our insects and invertebrates are taken care of at the butterfly house. So thank you guys so much. And I really appreciate everyone being there. See you guys later.